Hello everyone, thank you for watching this video. As I was driving this weekend in traffic, of course we're in LA, I kept staring at the multitude of cars around me and I was like, okay, these are pretty nice cars, but what does really make the beauty of it? And the image of the engine popped up right away in my head. So here I am today trying to make you see the beauty of a car engine through physics and thermodynamics. Let's jump right into it. First, what is it? A combustion engine is a complex machine. It operates by burning fuel to produce thermal energy and then uses the energy to do work. In a car, the engine does the work of providing kinetic energy that will obviously turn the wheels. The combustion engine in a car is a type of engine called an internal combustion engine. Another type of combustion engine is an external combustion engine. So, how does it work? An internal combustion engine burns fuel internally, or inside the engine as its name suggests. The engine works in a series of steps which keep repeating. First, a mixture of fuel and air is pulled into a cylinder through a valve, which then closes. A piston inside the cylinder moves upward, compressing the fuel-air mixture in the closed cylinder. The mixture is now under a lot of pressure and very warm. A spark from a spark plug ignites the fuel-air mixture, causing it to burn explosively within the confined space of the closed cylinder. The pressure of the hot gases from combustion pushes the piston downward. The piston moves up again, pushing exhaust gases out of the cylinder through another valve. The piston moves downward again and the cycle repeats. Now, before going into more thermodynamics concept, I would like to present a general idea about the relationship between an engine and the wheels. In a car, the piston in the engine is connected by the piston rod to the crankshaft. The crankshaft rotates when the piston moves up and down. The crankshaft in turn is connected to a kind of long metallic tube called the driveshaft. Its exact definition is a driveshaft is a mechanical component for transmitting torque and rotation. When the crankshaft rotates, so does the driveshaft. The rotating driveshaft turns the wheels of the car. An external combustion engine is a heat engine where a working fluid contained internally is heated by combustion in an external source, through the engine wall or a heat exchanger. The fluid then, generally air or water, by expanding and acting on the mechanism of the engine, produces motion and usable work. Back to internal combustion engines, Otto cycle. The most used engine in cars is called a 4-stroke internal combustion engine, which runs on gasoline, diesel, compressed natural gas, or propane. The Otto engines are called 4-stroke engines. Let's remind ourselves about the Otto cycle and what we learned in chapter 20. This figure shows a PV diagram for an idealized model of the thermodynamic processes in a gasoline engine. This model is called the Otto cycle. At point A, the gasoline-air mixture has entered the cylinder. The mixture is compressed adiabatically to point B and is then ignited. The heat, QH, is added to the system by the burning gasoline along line BC, and the power stroke is the adiabatic expansion to D. The gas is cooled to the temperature of the outside air along line DA. During this process, heat, QC, is rejected. This gas leaves the engine as exhaust and does not enter the engine again. But since an equivalent amount of gasoline and air enters, we may consider the process to be cyclic. Let us see a real car engine to help us visualize the process more easily. I will use my car as a model for the project. The engine that I am about to show you is a V6 3.7 liters. What does all this mean? A V6 engine is basically one that has 6 cylinders. A cylinder is the power unit of an engine. It's the chamber where the gasoline is burned and turned into power. Every vehicle has cylinders, and the engine size is generally denoted by how many cylinders a vehicle has. A 4-cylinder has 4, a V6 has 6, and so on. And inside each cylinder is a piston, which moves up and down as I explained it before. Let's turn on the ignition now. After the ignition is turned on, a whole bunch of electromagnetic processes happen in the car. Although very important for an electrical engineer, it is not necessary to present in this video. However, what is important to know is that after ignition, a high voltage is created and will therefore create a spark in all the cylinders that a car contains, 6 in my example. The pistons start then moving up and down according to the schema that I presented earlier. And the movement of the pistons will consequently turn the timing belt that you can see over here, responsible for synchronizing the rotation of the crankshaft and the camshaft, and regulates the opening and closing of the valves. Whenever you press the gas pedal, the motion of the pistons becomes faster, and power produced increases, and the work done increases over time. Consequently, rotations of the drive shaft, the long tube, increases too, which makes the wheels of the car turn faster, and that is how a car operates. Magic, right? Thank you for watching this video. I hope that you can now admire the beauty and genius of the idea behind a car engine the way I do. Although I did not present other important parts of the system, such as the importance of the coolant, the antifreeze or oil, radiator and all that, I hope that you can now show off to your car mechanic the next time you go there.